Let's enter into the topic. The fundamental focus of the topic is you'll be seeing about what exactly data and what are the various insights of data we have. When you are speaking about the data, we need to speak about multiple concerns facing with the data. And once you have the data, how you are going to build a model for the data. For building the model, today we'll be speaking about one technology called as machine learning. So before entering into the topic, let it be data to insights or machine learning. First, understand what exactly a machine learning is and how the system is working in the case of a machine learning. We all know that we are done with the C programming, C++ programming, Java programming or whatnot, which will be calling it as a traditional programming. Similarly, a machine learning is also a programming. The fundamental difference between these two is, in the case of a traditional programming like your C programming or whatever it is, let us take an example. I have some A equals to 5 and B equals to 5. To perform the addition
Hello,
of
sir.
two numbers, I will be writing C equals to A plus B as the function or the code. Then I'll be getting the result as C equals to 10. A value I'm giving, B value I'm giving, and what is the logic of addition of two numbers? C equals to A plus B also I'm giving in the case of a traditional programming. That is what we have seen so far. Whereas in the case of a machine learning, you'll give the A value as 5, B value as 5, and C value as also 10. Then the system will give you what is the relation of A, B, C, that is C equals to A plus B, which is not happening in the case of a traditional programming. Here the machine itself is giving the relationship between among the variables. That is the fundamental logic of your machine learning. So moving further, we should know what is data first. If I say something like 2, 4, 6, 8, 10, what does it mean actually? I'm not saying that they are the multiples of 2. I'm not saying that there are some numbers. I'm just saying that they are multiples of 2. That
Hello,
means
sir.
that, yes ma'am, I'm not
Hello,
saying that,
sir. Sir, sorry to interrupt. Can you introduce yourself and start the session?
yes. Are you facing any difficulty?
Can you introduce yourself and start the session?
Ma'am, we already started. We're in the middle, no? No problem. Last we'll see. Thank you. So we are saying about the data. Let us say that we'll be calling it as 2, 4, 6, 8, 10, some random numbers we are giving. I'm not saying that these are the multiples of 2, these are some numbers, just we are displaying something. That means that anything without having any context, without having any meaning, we'll be calling it as a data. It can be numbers, it can be in alphabets, it can be special characters or whatever it is. If you add some flavor called as meaning or some context, we'll be calling it as a information. For the same example, 2, 4, 6, 8, 10, I'm saying it as these are the multiples of 2. That means I'm adding a context or some meaning here that these are the multiples of 2, which will be calling it as information. Moving further, you'll be applying something like expertise. When you know 2, 4, 6, 8, 10, with your experience and with your expertise, if you are able to write 12, 14, 16, 18, 20, and so on, we'll be calling it as knowledge. This is the fundamental difference between your data, your information, and your knowledge. In the case of a data, you don't have any meaning, you don't have any context. In the case of an information, data plus some context or meaning, we're saying it as an information. In the case of a knowledge, information plus expertise, will be calling it as a knowledge. Now, moving further, when you are saying data, alphabet is a data, numeral is a data, special symbol is a data, group of words, combination of all these things is a data. Do you have any categorization among the data? Do you have any various types of data? That is one of the important thing in your machine learning, how you are going to work. So for that, we have various kinds of data. Let's see here. Basically, we'll be discussing about two kinds of data. The first one is quantitative data, and the second one is qualitative data. In the case of a qualitative data, let's move to the qualitative data first. So we have two categories. One is nominal and the second one is ordinal. If you look at the nominal data, if you want to name some variables, if you want to name some colors, if you want to name some states, we'll be calling it as a nominal data. Let us say color, red, white, blue, yellow, which is your nominal data. Coming to the ordinal data, which will be having some set of order basically. Let us take grade as an example. A grade will be A, B, C, D, E, and so on, which is having an order, which we'll be calling it as an ordinal data. Now get back to your discrete data and continuous data. In the case of a discrete data, let us take an example, profession. So what are the various types of professions we have? Teacher, driver, doctor, anything will be a discrete data. And there is a relation between your nominal data and discrete data. Understand here very carefully. In the case of a discrete data, you are taking profession. In the profession, we have multiple categories. But whereas in the case of a nominal, you will take one of the profession. Let us take teacher. A teacher can be primary school teacher, higher school teacher, secondary school teacher. If you are dividing this particular part teacher into multiple categories, you are making it as a nominal attribute. The profession itself, teacher, driver, doctor, or whatever it is, if you are speaking in the high level, we'll be calling it as a discrete data basically. So moving further, you have something like continuous data. Basically, the discrete data is having a finite set of data. That means it is countable. You have some limit on the data. Let us take pin codes. You have some limit of the data. But whereas continuous, which is infinite number of data, there is no limit for the data. If you take an height of the person, let us say person is 5.5, the other person is 5.6. In between 5.5 and 5.6, we have infinite number of values. N number of people can be accommodated in between 5.5 and 5.6. Let us take weights as an example. Suppose the X person weight is 67.4. The Y person weight is 84.5. In between these, how many values you are going to get it? If you take 86.5 to 87.5, between these, how many values you are going to get it? So you cannot count it. So those type of data will be calling it as continuous data. So this is the fundamental difference between what are the various types of data you have. So based on these data sets, so you are going to apply your machine learning algorithms. So which algorithm will be very efficient, very good for what type of data is the fundamental task in your machine learning algorithms. Moving further, Jesse, these are the various examples for the various categories of data. So you can go through this, it is already discussed. Now, what do you want to the machine learning to do? So what you are expecting the machine learning? So when you have some set of data, so what kind of machine learning you are focusing? When you have other set of data, so what type of machine learning you are focusing? Basically, in the case of a machine learning, we have three approaches, which are the fundamental approaches. One is supervised learning mechanism. The second one is unsupervised learning mechanism. The third one is reinforcement learning mechanism. Now, when to use which approach is the fundamental scenario here. Suppose look at this particular slide. So I want to learn what actions to take in different situations. When you speak about actions, which is nothing but you are speaking about your environment. When you are speaking about your actions, your learning will be by default reinforcement learning. So now look at here. I want to learn what actions to take in different scenarios. Now there are two cases here. One is active case and the second one is passive case. If it is active case, if it is active case, so we'll go for reinforcement learning. Again, if it is active case, and if the system is not in a position to gather data by trying sequence of actions, the machine learning is not useful. Basically, if you take the reinforcement learning, you are gaming whatever you are doing, let it be Mario, let it be Sudoku. So all these things are coming to your reinforcement learning mechanism. Now the logic here is when you are working on a particular game, you'll be doing some actions. Actions are nothing but your movements. How you are doing the movements based on your environment. That environment is nothing but your gaming scenario. When you are not doing any movements, when your system is not allowing you to do any set of movements, will you able to do the gaming? Will you able to complete the game? No. That means you are not able to interacting with the environment. In that case, the machine learning will not be helpful. Suppose if you are able to interact with the environment and if you are able to do the actions, if you are able to learn the things from the actions based on the environment, we'll be going for reinforcement learning. This is one of the learning mechanism. Next, I want to see if there are natural clusters or dimensions in the data I have about different situations. Something like I have some data. I want to group the data at one place. Let us say I have a class data, all the boys at one place and all the girls at one place. Or all the short boys, short girls, tall girls. Four different categories I want to place. I know the number of students. I know their heights. It's easy for me to segregate who is coming under short girls, short boys, tall boys. So in this scenario, you have something like unsupervised learning mechanisms. In detail, we'll see later. Similarly, I want to learn what actions to take in different situations. If it is active, I'm directly going to the reinforcement learning. If it is passive, the fundamental difference between active and passive here is in the case of an active, the system itself will generate some actions. In the case of a passive, the system will learn from historical data. That means you are going to train the system. When you train the system will train, the system will know, the system will have some set of knowledge and behavior. Now, when you give new sets of data, which we'll be calling it as testing data, it will react. If you have this kind of category, training and testing, if you want the machine learning system to learn from the data, and when you give your new inputs, your system wants to react, you have an option called as supervised learning mechanism. These are the three situations how you need to take up or how you need to choose what type of learning you want to proceed with. Moving further. Now we have seen data. We have seen what type of methodologies in machine learning can be done. Between these, there is a procedure. The first and fundamental thing is you need to collect the data. Once you have, you need to go for data pre-processing. Next, we'll be going for feature extraction and selection. Next, we are converting the data into two parts. One is training data, which is used for model building. Next, you are selecting your model here. That means you are using your any of the ML algorithms. So based on the training data, you are supplying training data to the model. So which itself is model training. Then you will be supplying your testing data here. Based on the testing data, how far it is working perfectly, we'll be using called as model evaluation. So once the model is evaluated, it has to be deployed. Deployed in the sense whether it can be an app, whether it can be a website for user friendly. Once it is deployed, there should be a maintenance and monitoring for this. So why it is important, each and every stage will be seen now. So before data collection, we need to have a fundamental thing, which is nothing but your problem statement or problem definition, which will be very important in your projects also. If you want to work on anything, what is your problem actually? What is the problem statement? That itself is nothing but your domain basically. Whenever you are selecting the projects, the two fundamental things is what is your domain and what is our application. So understand here carefully when I'm speaking about the domain. Let us say I want to work on a particular disease called as Alzheimer's. So Alzheimer's belongs to which category? Healthcare. So my domain here will be healthcare and my application here will be your Alzheimer's. Let us say I want to predict rainfall. So rainfall will be coming under weather forecasting. My domain is weather forecasting and my application is rainfall. I want to go for credit card risk assessment. It is coming under banking. So my domain is banking and my application here is credit card assessment, something like that. So the first thing is you need to have a problem statement. In the problem statement, your focus should be on what is your domain and what is your application. When you have a domain, you'll be sticking to a particular application. Let us say here I'm taking it as a case study, healthcare problem. So once you have identified, let us say you want to work on Alzheimer's disease. What is your target? You'll be having multiple features or attributes or values. What you want to go, what you want to see? Yes, no, Alzheimer's is, Alzheimer's no. That is nothing but your target variable. You need to be very clear with your target. What is your target variable, which you will be calling it as class variable. Once these two are done, what is the existing literature? What is the success criteria of this particular application? In the literature, you will be finding it. When you do this, it helps us to set clear what are the research questions we have, and it will help us to create our own goals. So how we are going to do, you need to, it's not about speaking orally. You need to maintain at some place. It can be Word file, it can be an Excel file, it can be a Google Doc, some documentation you need to do it. So this is the first stage before collecting the data. Why this is very important? If you want to collect data, you should know what is your domain, what is your application. So related to that only you will be able to find it. It's not about again identifying the domain and application. Even in the application, you'll be having a number of cases. To what case you are working, you need to set your goals. You need to have some sort of scope. So for all those things, this particular stage is very important, which is nothing but your problem staging, problem definition, and goal setting. Moving further, the first step is data collection. Where to get the data is very important. Various data sources are available for us. We have some set of websites. You might be heard about Kaggle, GitHub, UCI. Like that, you have multiple sources for collecting the data. These data sets, these repositories are public repositories, and the data sets are benchmark data sets. Benchmark data sets in the sense they are already evaluated, they are already authorized by some set of experts. Let us say when you are working on a particular Alzheimer's disease, it's a very sensitive data related to the medical industry. So what is the ethics you are following when you are using the data? So you cannot take a person's personal data and you cannot experiment it. There is some set of ethical concerns. There are some set of security concerns. So medical data is very sensitive data which you will not be get it. But in the repositories, there is some benchmark data sets. That means that they have taken approval of the patients. They kept it openly available. Those who wants to carry out the research, those who wants to do the projects, they can readily take the data from government or some websites. This is about taking the data which is readily available. Second thing, you want to generate your own data. We have something like Internet of Things, IoT devices, where you will be using some sensors. You might be hearing about weather sensor, temperature sensor, humidity sensors, fever sensors, something like that. We have multiple sensors related to particular application. By making use of sensors, you can able to collect your own data sets, which is very important. But when you are generating your own data sets, what is the authenticity of your data is very important. Who is going to evaluate your data? It's not about you are collecting your data on your own way. There should be some authorization of the data, which is one of the fundamental issue when you are generating your own data. The other option of creating your data set is you can prepare a questionnaire, you can prepare a Google form, you can prepare a Google sheet and share it with multiple people. You get the responses of them, which is one form of the data. Again, what is the authenticity? These are the various types of data source. We're not going in much, so just have an idea. When you have these data sources, how you are going to collect the data? So what we are doing is a simple Excel file we are doing, but professionally it is not correct. So we need to have some set of application programming interfaces, or robotic process automations, or web scraping, or intelligent document processing in order to collect data. So once the data is collected, how you are going to store? And the second thing is how much data you want to collect. Once the data is collected, where to store the collected data is very important. So we have multiple sources. We can create an SQL database. You can create a data warehouse. You can create a data log. It can be anything. When you are working in any application, the first thing is you need to have your data, which means that you need to collect the data, which is one of the fundamental and the first stage in the case of your machine learning. That is what we have seen. Next, what are the various repositories? That is what we have seen. What are the various sources? Your Google data search, AWS, Microsoft Research, Kaggle, UCI, government sources, OpenML, GitHub. We have multiple sources for collecting the data. Once you are done with the collection of the data, the second thing is you need to go for data pre-processing. Now the question is, why do you know this particular step? When you collect data from online, sometimes your data will be having some missing values, some random values, some duplicates, some error values, which will be calling it as outliers. There are multiple issues in the data when you're collecting data from various sources. Before building the model, before supplying this data to the model, it has to be clear. The data must be clear. The data must be clean. So for that reason, we are going for data pre-processing. What exactly it will do if you do this data pre-processing? It ensures data integrity and consistency. It improves the model performance when the data is clear. Let us see various examples. How you are going to do the data pre-processing. These are the various approaches we have. First, we'll see about the missing data, noisy data. Look at this particular data. This data is being collected from internet. Now look at here, there is an empty space. There is an empty space, empty space, empty space, empty. There are some sort of missing values here. My model will not work if the data is not complete. So either you should remove the tuples or you need to rectify the tuples with some set of values, which is one of the important thing in the data pre-processing. How you are going to do this? We have multiple techniques. You use the mean value. You have some age factor here. Take the mean, fill the value, or median, something like that. You take multiple values, you do it, you get it done. We have multiple approaches. This is one set of missing values. There is something like noisy data. Look at here, there is something like sex, male, female, which is common. If I say something like youth here, Assume that in the place of male, you have an youth. Is it correct data? It's a noisy data basically. Youth is nowhere related to the sex factor here. So it has to be rectified. So those things are to be very careful whenever you are doing the data pre-processing, which is first important factor in your data cleaning. Once the data is perfect, once the data is cleaned, all the values are filled and there is no noisy data, still you have a problem. The second step you are going to do is data transformation. So basically people will speak about data integration. So that is not that much important. So we're directly jumping into the data transformation. So in that we have multiple categories. One is normalization, attribute selection, discretization, concept hierarchy generations basically. So what is normalization basically? Look at this particular table. Names, it is common. Look at salary, years of experience, expected position level. So when you look at this as a human analysis and behavior, your eye will directly go to the salary attribute, but it will not go to the years of experience and expected position level. The reason is the salary, the values inside the salary are very high values. The data always should be balanced. I should not be focused only on one particular column. It should be equal to all the columns. That means you need to do the normalization for this particular attribute salary. Basically, normalization will be scale minus 1.0 to 0.0 or 0.0 to 1.0. So these values will be converted to that particular scale. So that is what you are going to do the normalization. There is something like discretization again. Let us say there is one more attribute here, something like age. Ages are something like as their employees 25, 35, 40, 60, 55 like that. When you have 100 records, so we can do it manually. 100 records we can able to read, you can able to see what are the different ages. When you have 1 lakh records, how can you say that how many people are working with less than 30 years, with less than 40 years, with less than 50 years? You need to fix some interval. 20 to 30 years are youngsters, 30 to 40 middle aged, 40 to 50 seniors, 50 to 60 seniors, super seniors. So when you are focusing on the interval range, when you are converting your data into interval range for better visualization purpose, we'll be calling it as data discretization. That is one of the important tasks in your data pre-processing. Next, data cube aggregation will be same. Look at this particular data. So I have 2008 data. 2008 data is having 4 quarters, Q1, Q2, Q3, Q4. Similarly, I have 2009 data, 2010 data. So when you are looking at 2008 is visible to me, 2009 is back, 2010 is back. So like this, how many backs I need to go? So for that reason, why can't I aggregate this data? Why can't I combine this data, all the 2008 at one place? The combination of the addition of these values, next 2009, the addition of these values, 2010, the addition of these values, this will overcome the computational complexity, the space complexity which you are facing the problem here. Like this, we have multiple pre-processing steps. So understand now what is data, how we are going to collect the data, and what is the requirement for pre-processing your data. These are the fundamental things which you are going to do it. Now, after pre-processing, what you need to do it. It's not about directly submitting data to the model. You need to analyze your data. You need to see your data. So analyzation in the sense, it's not about if you see the table, you cannot analyze the data. It has to be visually presented. So visually presented in the sense in the form of a graphs, in the form of a trees. So when you are representing in the graphical format of your data, we'll be calling it as data visualization, which is one of the important thing in your exploratory data analysis. When you represent your data in the form of a data visualization or in the form of various graphs, you will see the statistics with your human eye. And you will see how exactly your data is distributed. And if you can see what are the correlations, how one attribute is depending on the other attribute. and what are the trends in the data, what are the various patterns, what are the various frequent items. So all these things you can able to see when you are able to demonstrate your data in the form of various visualization techniques, which will be the one of the important factor in your machine learning process. We'll be calling it as exploratory data analysis. The fundamental logic why you are doing this is it will give you the hidden patterns. And the second thing is you'll be having some set of features or attributes. There might be some scenarios where you need to generate new features. When you have your data visualized, then it will give you an idea, some picture, some features are needed now. You need to generate some features. Let us say there is an age attribute. Let us say there is a date of birth attribute in a particular table. So when I visualize the things, for my model, I might be required age, but age is not available in my data. But date of birth is available. So I can add my new feature. So all these things can be known when you have your data visualization. So the fundamental tool we have something like Tableau, which you have heard most of you. So before doing anything, play with the data. So playing the data is nothing but your data visualization, which is the exploratory data analysis. So now when to use what type of visualization is very important. It's not about graphs. We have so many graphs, pie charts, bar graphs, scatter graphs, line charts. When to use what is very important. Now let's see. When you want to compare the things, you want to compare the various house rates in particular years. You want to compare the past percentage of students of various years. When you have some text like this, when you have a situation like this, when you have a context like this for comparing the things, you can go for either line charts, you can see here, or bar charts. So like this, you have multiple charts. So the fundamental when you want to compare will be using bar charts or line charts. When you want to distribute the data, when you want to see how the data is distributed, you'll be going for, see this here, histograms and scatter plots. This will show the distribution of the data. When you want to show, when you want to see what is the relationship among attributes in the data. Let us say I have two attributes. What is the relationship? I'll be going for scatter plot or bubble chart. So look at here. There is one bubble, two bubble. These three are one size. This is one size. This is one size, and this is one size. It is showing the relationship among four different variables here. When you have more than two variables, you'll be going for a bubble chart. When you have only exactly two variables, you'll be going for scatter plot. When you want to see the composition, the fundamental chart we have is pie chart. Clear when to use what? And for this distribution, we have one more chart, which is nothing but your box plot basically, which will be knowing it. You take any data, which will divide the data into only two parts. The box plot will divide the data into four equal parts, that is Q1, Q2, Q3, Q4. You have 100 records, less than 25 at one place, less than greater than 25 to 50 at one place, greater than 50 to less than 75 at one place, greater than 75 at one place, where you are going to exactly cut your data into four equal parts, which is nothing but your box plot, which is completely based on quartiles Q1, Q2, Q3, Q4. The fundamental usage with the box plot is when you divide the data into four equal parts, you know what is the minimum value and will be knowing what is the maximum value. When you are giving the new data, if it is below the minimum value or after the minimum value, which is nothing but your error data, will be calling it as outlier, which you will be able to identify with the making of box plots basically. This is about your data visualization. Next, once you have visualized, once you find out the patterns and all those things, your data is ready. Now you need to do some future engineering and future selection. Do you need any new features? Do you need to have any meaningful features? Or all the features are required for the model, or only few features are required for the model is the question. Suppose You have a table. Table is having weight and height. But you need BMI, which is not available in the table. You can calculate if you know the weight and height. That means you are adding a feature which is very important, which is a meaningful feature. Let us take an example. I have a student database, student roll number, student name, first year marks, second year marks, third year marks, fourth year marks, grade. I want to display grade of the students. When I want to display the grade of the student, I can take only grade attribute and the roll number attribute. What is the need of this name? What is the need of first year, second year, third year, 4 marks? These are called dimensions. These are called attributes. These are called futures. Sometimes you need to limit your dimensions. You need to reduce your dimensions which are not useful in the model. So this is how you are going to do it. So when you do that, automatically your model efficiency will increase. Moving further. So till here, you have your data, clear cut data, which is having all the features, all the important features. Your data is ready. Now you need to select your model. So what is your model here? You have multiple models in machine learning, supervised learning model, unsupervised learning model, reinforcement learning model. Depending on your problem statement, you will be going for what type of model you want to choose. When you want to find the patterns, when you want to find the frequent item sets, you'll be going for unsupervised learning mechanism. One of the unsupervised learning mechanisms will be clustering. The other will be association rule mining. Like that, we have multiple. If you want to go for some predictions, if you have to go for some classifications, we have classification prediction techniques, regression models. We'll go for that. When you want to work based on the environment actions, you'll be going for reinforcement learning. Like that, you can choose any one of the model based on your problem statement. So my problem statement, according to this particular case study, is healthcare. That means I want to classify, I want to predict whether the patient is Alzheimer's affected or not. When I want to go for classification prediction, I'll be going for one of the supervisor learning mechanisms. Let it be decision tree, support vector machines, K-name classifiers, or navy-based classifiers, or random forest, or various ensemble methods. I can pick any one of the model. Now, when to use what type of model? We have supervised, unsupervised, reinforcement. Forget about this semi-supervised. It's in detail. When I have to, something like my problem statement is housing price predictions, I'll go for regression models. When I want to go for medical imaging, I'll go for classification tasks. So both the tasks are belonging to the supervised learning mechanism. When I want to go for segmentation, you have an image, you want to segregate that image, you want to segment that image, you want to divide that image into multiple images. Let us take, you are taking a satellite image. When the satellite is taken from the top, it takes the cloud, it takes the green pot trees, it takes the lakes, it takes the humans, it takes the buildings, it takes the roads, it takes everything. You want to split all the roads at one place, you want to split all the trees at one place, you want to split all the clouds at one place, which you will be calling as segmentation, which we are going to do using the clustering. Or all the tall boys at one place, short boys at one place, tall boys at one place, short girls at one place, which we will be calling it as grouping, we'll be calling it as clustering. Or you are going to a market. So what are the frequent items? When you are buying a bread, what are the chances of buying butter, cheese, yogurt? When you want to analyze those types of frequent items, you'll be going for your association rule mining, which is nothing but your market basket analysis. When you want to work on the actions, when you want to work on the sequences, on the environment, you'll be going for reinforcement learning. This is how you are going to choose what type of model you want to use depending on your scenario. Next, model training. When you have your data, when the model is ready, your data will be divided into two categories. One is trained data, second one is test data. Basically, as per the research, 80% of the data is given to training purpose and 20% of the data will be given to testing purpose. The fundamental question here is, if you do this particular format simply, Let us say I have 10 records related to Alzheimer's. First 8 records are saying the class Alzheimer's. Last 2 records are saying non-Alzheimer's. Now how my training data will be split? 80%, right? Which 80% I need to take? Basically, as a human perspective, you will be taking first 8 records for training and last 2 records for testing. So when you are training the model, all the 8 records are related to only one class, Alzheimer's. Your model is well trained with Alzheimer's. Now your test data is having non-Alzheimer's. When you try to evaluate your model, will it give you correct result? No, it will not give you the correct result because your model is not trained with the correct data. So when you are doing the training and testing, it's not about taking directly. You need to have some techniques. So one of the technique basically in the machine learning will be using is cross validation techniques. Here the data will be shuffled. You have one of the approaches of cross validation technique, which we will be calling as k-fold cross validation techniques. K will be depending on the user. Basically, we will be going for k equals to 10, which is an optimal value. That means first we take 8 records for training, first 8, last 2 for testing. Second case, first 2 records for testing and the last 8 records for training. In the third case, first record and the 10th record for testing and the remaining records will be for training. Like this, you will be going to shuffle the data, you will be getting multiple performance values and we are going to find the mean value of all these things. That will be your optimal efficiency value. This increases your generalization of the model. And the second thing is there is something like overfitting and underfitting. Sometimes when your model is trained, 100% you will get for training and 0% for testing. That means your model is overtrained, which is nothing but overfitting. Sometimes your model is not performing well for the training data set and your model will outperform for the testing data set, which is nothing but your underfitting. These two things are carefully dealt in the case of a machine learning algorithms. Training data high, testing data low, or testing data high, training data low is not an optimal solution. Both training and testing data performance measures must be an optimal, which is an optimal solution. Once the model is done, next you are supplying your testing data. So based on the testing data, it will give you the results. These results are to be evaluated in the form of various evaluation metrics. The various evaluation metrics will be having are accuracy, precision, recall, F1 score, AUC curve. So these are the fundamental performance measures when your focus is on classification and prediction techniques. When your focus is on regression techniques, you can go for mean square errors, root mean square errors, mean absolute errors, R2 squares, or many other factors which we are having. So how we are going to generate these all values in the sense we have a confusion matrix. So we can see the confusion matrix which we will be knowing. So based on that, you are going to generate all these factors. Other than this, you can put some sensitivity, some specificity, some dice, some F1 score, some kappa statistics. There are multiple values. So when the model is done, you are evaluating the model. Why you are doing this evaluation of the model? In order to know the effectiveness of your model, if the model is not appropriate, you need to improve the model. To do these things, you need to go for this model evaluation. Your task is done, you are giving input, you are giving output. This is what we are saying in the machine learning. But as a programmer, you know how to give the data and how to get the data, how to run the code. But some layman wants to use that particular application. Let us say you are doing a Alzheimer's, non-Alzheimer's problem, it is done. Suppose as a layman, I want to check whether I have Alzheimer's or not. So I don't know how to give my input data in detail. I don't know how to read the code. I don't know how to read the output. There should be an interface for me. I will log in. I will enter my details. So I have my anxiety level is there like this. I have my stress like this. I have strain like this. My model should give the output. That means there should be an interface. That means you need to deploy somewhere. When you deploy, it can be a mobile app or it can be a website in the form of a website. So once you are done with your model, any model, it's not about ML, deployment is very important. Once the deployment is done, let us say 2010, You have developed a model. It is not same every year, right? The data is keep on changing. You need to do some updations to the model. It's not like you have done your model in 2010, 2050 also same model will be using. There should be some maintenance, there should be some monitoring to the model. So you need to see the how the model is performing over the time. You need to ensure that your model remains accurate when a new patient data emerges. Because as the technology is moving, more number of futures are trying to evaluated by doctors. Those for those characteristics also your model should give the correct outputs. So for this reason, we need to have a model monitoring and maintenance. These are the various stages of your machine learning technique. Now, what challenges you have, what technique, what applications, what projects where you can choose. You have some handwritten digits. You want to classify your handwritten digits. Machine learning is one of the option. For doing that, from where you will be getting the data sets. We have seen UCI Kaggle data set, right? Like that, you have something like digit recognizer or MNIST database. We can download the data sets and we can go for classification of handwritten digits. You want to identify the objects. You want to detect the objects from a picture or from a video. You can get it done. So we have two data sets. One is Oxford Pets data sets and the COCO data set. You want to go for sentiment analysis. You can go for machine learning approaches. For this, we have multiple approaches. Twitter US airline sentiment, Amazon product review. You want to predict the disease, which you have seen. You can go for machine learning techniques. You want to detect the fake news in the social media. Now we have seen so much of fake news, whether it is correct or not. You can go for machine learning approaches. What are the various tools to implement this particular machine learning? Simple tool is Weka. Other tools like R, Python, Google Colab, SAP, Rapid Miner we have. So all these things are fine. Don't we have any challenges in the machine learning? Obviously, the first and the fundamental thing is your data. In the data, whether your data is quality or not, whether your data is scalable or not, whether your data is interpretable or not, what are the ethical issues, what are the privacy issues, what are the security issues of the data, all the things is completely related to the data. So when you want to talk about your artificial intelligence, data mining, machine learning, deep learning, computer vision, image processing, or whatever it is, you need to speak about your data. You need to be very careful with your data because the data collection, data pre-processing is 90% of the work in your data in your projects, in your research. So how we are collecting, how we are processing your data is one of the major challenging thing in any of the project, but unfortunately we are not focusing on it. So model building, already the models are available, or you can do some modification to the model that can be done anyway. But how you are playing the data is very important. That is one of the important things before doing any of the machine learning concepts. So any technology will be having the future scope, future enhancement. Similarly, machine learning will be having. You can see the expandable AI now. Now data is moving to the big data with a huge number of records. We'll be integrating big data with machine learning techniques, which are already in practice. Now we are seeing IoTs. We have already seen in the industry 6.0 industrial internet of things, which is IIoT, industrial internet of robotic things, industrial internet of medical things. There are many things from smart environment which is coming into the picture. So these are all the future trends of your machine learning.